What are Young's modulus?
Applied pressure, called stress, divided by the ratio of the change in length to the original length, called strain.
Which car has the larger acceleration?
Both have the same change in speed. But the sports car requires less time to make the change, so it has the larger acceleration. Like velocity, acceleration is a vector. That is, it includes both magnitude and direction. In speeding up, in which the change in velocity is positive, acceleration is a positive quantity. If the object is slowing down, then the acceleration is negative. If, however, the object is going in the negative direction, for example, a car going in reverse then speeding up, is a negative quantity because the final velocity is more negative than the initial velocity. Physicists do not use the term deceleration. Whether positive or negative, speeding up or slowing down, the term acceleration is always used. The table below shows some typical accelerations in a variety of units. The rightmost column, labeled g, compares the acceleration to that of an object falling in Earth's gravitational field. This ratio is frequently used in both everyday and scientific writing.
How did radio communications develop?
An electromagnetic wave with no changes in amplitude or frequency. Carries no information. It cannot be used for communication. The first method of using these waves to communicate was to switch them on and off in regular patterns. Letters were represented by a combination of long and short pulses using what is called Morse code after Samuel S.B. Morse, who developed the code to transmit information over wires, the telegraph. In 1895, Guglielmo Marconi, 1874 to 1937, a 20-year-old Italian inventor, created a device that transmitted and received electromagnetic waves over a 1 kilometer, 3,280 foot, distance. Later improvements to his antenna and the development of a crude amplifier enabled him to receive a British patent for his wireless telegraph. In 1897, he transmitted signals to ships 29 kilometers, 18 miles from shore, and in 1901 he was able to send wireless messages across the Atlantic Ocean. As a result of Marconi's work on radio transmitters and receivers, he was the co-winner of the 1909 Nobel Prize in Physics. Over the next decade, transmitters and receivers were improved enough that they could be installed in ocean-going ships. Voice communication over the telephone had existed since 1876, but if the distance was to be extended, the voices had to be amplified to be heard. In 1906, Lee De Forest invented a vacuum tube amplifier he called the Audion. It took until 1915 for a radio receiver to be sold using audience. In 1916 De Forest had developed an audience-based transmitter that allowed dance music to be transmitted 40 miles. A number of other experimental stations demonstrated music by radio, then called wireless. A large number of radio amateurs made significant advances. When the United States entered World War I in 1917, all stations not owned by the government were shut down, and it became illegal for people to listen to any radio transmission. Samuel S.B. Morse was famous for inventing the Morse code that allowed people to first transmit messages over telegraph wires. During the war, radio was used to communicate between ships and between land and the ships. After the war, amateurs were forced to use only one wavelength, 200 meters, 1500 Hz. Wavelengths shorter than that were thought to be useless for government use. One amateur was able to send signals 3,000 miles. In 1921, transatlantic voice transmissions were made. Companies began to use radio for specialized needs, like to send time information to jewelers to allow them to set their clocks. From 1919 through 1921, radio was mostly used to transmit musical concerts. The first transmission of a football game occurred in November 1919. By 1922, newspapers had developed radio stations transmitting news, weather reports, crop reports, and lectures. Large companies such as General Electric, Westinghouse, AT&T, and RCA began to be involved in developing commercial broadcasting. From 1922 to 1923, as the number of stations grew without regulation, chaos reigned. In 1928, the government announced new assignments in the frequency band 550 to 1600 kHz. Many more assignments were added after World War II, but these regulations are still in use today.
What happens in there is no force?
The equation says that there is no acceleration. That is, if the velocity was zero, it remains zero. If the object was moving, it continues to move with the same velocity. These statements are called Newton's first law of motion.
In what ways do atoms emit and absorb light?
In the mid-1800s, Robert Kirchhoff published 3 laws that describe how materials emit and absorb light. 1. A hot solid or a hot, dense gas produces a continuous spectrum. 2. A hot, low-density gas produces an emission line spectrum. 3. A continuous spectrum source viewed through a cool, low-density gas produces an absorption line spectrum.
What would happen if the cable holding the elevator would break?
U and the elevator would both be in free fall, accelerating at g. There would be no weight shown on the scale. U and the elevator would both be in the state of apparent weightlessness. We'll meet this term again when we explore the motion of satellites. The apparent weightlessness of astronauts will be explained there.
What is the uncertainty principle?
Limitation to simultaneous knowledge of position and momentum of particle, dx dps equals h/4p. Equivalent equation for energy and time.
What is amplitude modulation, AM?
M-wave amplitude changes to represent transmitted information.
Does the speed of light depend on the medium?
Waves travel at different speeds when traveling in different materials. In the vacuum of space, light travels at 299,792 kilometers per second. When light encounters a denser medium, however, like Earth's atmosphere, it slows down ever so slightly to 298,895 kilometers per second. Upon striking water it slows down rather dramatically to 225,408 kilometers per second, 3/4 of its original speed. Finale, when light passes through the dense medium of glass, it slows to only 194,670 kilometers per second. The ratio of the speed of light in a vacuum to that in a medium is called the refractive index, represented by the symbol n. The refractive index will be discussed in further detail in the section on lenses.
What is lepton generation?
Each generation has a charged and unchanged arged particle. In first electron and neutrino, in second muon and muon neutrino, in third tau and tau neutrino.
What is optics?
Area of study within physics that deals with the properties of and applications of light.
What is mass energy?
Potential energy, the result of the mass of an object first postulated by Einstein.
Why is it dangerous to operate electrical devices in bathtubs, showers, and over full sinks?
Although water reduces the resistance of the human body and thus makes it more susceptible to electrical shock. It is the plumbing that is the main hazard. Take, for example, a person who likes to watch a plugged-in TV while sitting in the bathtub. If the TV is not connected to a GFI protected circuit and fell into the tub, the water would come in contact with the 120-volt wires in the TV. With the metal plumbing of the tub connected to ground, the grounding path would cause a current through the water. Unfortunately, this translates into a bad day for the bather. An MP3 player or battery-powered smartphone is much safer.
How is GPS used?
One very important use of GPS is to send time signals that allow clocks to be calibrated to within 200 ns, 200 billionth of a second.
What is a hertz? Hertz.
Unit of measurement of frequency. Equals 1 cycle per second.
On a warm day, why do water droplets accumulate on the outside of glasses and soda bottles?
The water does not seep through the container, but instead comes from the air surrounding it. Water vapor is the gaseous form of water that is in air below the boiling point of water. As discussed above, it takes a larger amount of energy to vaporize water. So the molecules of water in the air have more thermal energy than do the molecules in the colder glass. So when the water molecules strike the glass, they transfer much of their thermal energy to the glass. The colder water molecules join together to form water droplets on the glass. The process is called condensation. Condensation also occurs on window panes when the outside is cold and the interior air is warm and humid.
What is radiation?
A means of heat transfer when infrared waves are emitted by hotter objects and absorbed by colder ones.
Does a mirror produce an image?
The light reflected from an object by a flat, or plane, mirror is not redirected, so it will converge again. What you see when you look in a mirror is a virtual image. It is located behind the mirror. Some of the rays from the object are reflected by the mirror and enter your eye. Your eye believes that all these rays came from a single point, and that point is behind the mirror. The image isn't real, it is virtual. Virtual images can also be formed by lenses. They cannot be focused on a screen.
What is a solar eclipse?
An eclipse of the Sun occurs when the Moon casts its shadow on Earth. As the Moon moves between Earth and the Sun, darkness falls upon the small part of Earth where the Moon blocks the light.
What is pressure of air?
At sea level about 101 kPa.
What is an evaporation?
Change from liquid to gas at a temperature below the boiling point.
Why do you feel an outward force on you when you are in circular motion?
When we introduced Newton's laws, we neglected to state an important warning. These laws work only in an inertial reference frame. That is a reference frame where there is no acceleration. A car, when it is speeding up, slowing down, or changing direction, is accelerating. Therefore, a person in the car experiences other forces. When the car is speeding up, you feel pushed back into the seat. When the car is slowing down, you feel yourself being pushed forward. When rounding a curve, you feel pushed outward. These are not real forces, but are often called inertial, fictitious, or pseudo-forces. For objects in circular motion there are two such forces, the centrifugal and Coriolis forces. The centrifugal force is the fictitious outward force you feel when your car is rounding a curve.
How can that be useful?
It's because the distance moved, output distance, is larger than what you move, input distance. And, therefore, the output speed is also greater. A baseball bat, tennis racket, and golf club can be considered simple machines in which high speed of the end of the implement is desired.
Why did Chuck Yeager go to such a high altitude to break the sound barrier?
Sound travels approximately 760 miles per hour in the warm, dense air found close to sea level. The cooler and less dense air is, however, the lower the speed of sound. Since air is less dense at higher elevations, physicists and engineers felt it would be easier to break the sound barrier at those elevations. Knowing the temperature and density of the air at 12,192 meters, 40,000 feet, above sea level, scientists determined that the speed of sound would be reduced to only 660 miles per hour. As an added bonus, engineers found that not only was the speed of sound slower at such elevations, but when the air has such low density, the parasitic drag, the drag due to friction, is very low as well. Therefore, to break the sound barrier, Jaeger traveled as far up as 13,106 meters. 43,000 feet, above sea level to both reduce the sound barrier and decrease the parasitic drag.
What is a watt, W?
Unit of power. 1 watt is 1 joule, J, per second, S.
Do rolling objects experience contact friction?
Whether it is a bowling ball rolling down the alley or a wheel rolling on the road. There is no sliding between the ball or wheel and the flat surface, so there can be no contact friction.
How can you convert latitude and longitude to a distance measurement?
A precise conversion is difficult because Earth is not a perfect sphere. Latitude is easier to convert. The circumference of Earth taken over the poles is 24,859.82 miles, which is equivalent to 360 degrees of latitude. Therefore 1 degree is equal to 69 miles. So, the north-south distance between two cities 5 degrees of latitude apart would be 345 miles. Longitude is more complicated. At the equator 360 degrees is Earth's circumference, 901.55 miles. But at the poles it is 0. So the conversion of longitude to distances depends on the latitude. If you use trigonometry to find the distance, you will find that the circumference at a latitude of 0 degrees is the circumference at the equator times the cosine of the angle 0. So, at the latitude 40 degrees, the circumference is 19,076 miles, and 1 degree of longitude is 53 miles. This result is only approximate because Earth is not a perfect sphere. For more accurate conversions, consult a website such as http://www.nhc.noaa.gov/gc-calcshtml.
What is the inner ear?
Consists of the cochlea and 3 semicircular canals that sense the bodous motions and give rise to a sense of balance.
Who was the first pilot to break the sound barrier?
On October 14, 1947, Chuck Yeager, 1923, broke the sound barrier in his Bell X-1 test plane, Glamorous Glennis. In order to reach the sound barrier, the X-1 was carried in the belly of a B-29 bomber to an altitude of 3,658 meters, 12,000 feet, where it was dropped. The X-1's rocket engine ignited and Yeager took the plane to an altitude of 13,106 meters, 43,000 feet. At this altitude, Yeager was able to break the sound barrier by traveling 660 miles per hour. The X-1 experienced a turbulent set of compression waves just before he broke past the barrier at Mach 1.05. Yeager kept the plane at this supersonic speed for a few moments before he cut off the rocket engine and headed back toward Earth.
What's the strength of the gravitational field of Earth?
Earth's mass is 5.9736 x 1024 kilograms and the gravitational constant is 6.673 x 10 to 11 nm2 kg2. At the surface of Earth, 6.4 x 106 m from the center, then g equals 9.8 n/kg. Thus a kilogram of meat, for example, experiences a gravitational force of 9.8 n toward Earth's center. Earth is huge.
What is a series circuit?
Electrical devices arranged in a single line allowing only one path for the charges.
What is latent heat?
Energy needed to change phase of matter.
What is an odion?
A vacuum tube amplifier invented in 1906 by Lee DeForest.
What is Maxwell's equations?
Four equations that describe the nature of electric and magnetic fields. What
is a tevatron?
Very high energy synchrotron at Fermilab, near Chicago, Illinois.
What is hydraulics?
Use of a liquid in a device, usually a machine such as a pump, lift, or shock absorber.
What are composite materials?
Modern composite materials use carbon fibers with very high tensile strength but Low compressive strength to increase the tensile strength of brittle materials.
Who invented the electric light bulb?
The first person to generate light from a wire filament was the British Sir Humphrey Davy. Davy was known for his work on electric arc lamps in the early 1800s. And his breakthrough discovery was the first electric light. His lamp used a very thin piece of platinum wire that had high resistance and emitted a soft glow. The lamp didn't last long, and so it was not practical, but it did pave the way for others.
What is the refractive index, N?
Ratio of speed of light in a vacuum to that in a medium.
What is a proton?
Positively charged particle in nucleus.
How are acceleration and force related?
If you have a miniature toy car or even a smooth hard ball that can roll on a smooth level surface, you can explore the effects of force on motion. When the toy car or ball is motionless, give it a gentle tap with your finger. Note how it moves. Now, while it is moving, give it a second, then a third or even a fourth gentle tap. What happened? You saw that when the toy car was at rest and a force was exerted on it, it started to move in the direction of the force. When a force was applied in the direction of its motion, it sped up. Each additional tap caused it to speed up more. What do you think would happen if you were able to exert a constant force on it while it was moving? It's difficult to do. But try it. You can conclude from this exercise that a force applied in the direction of motion causes it to speed up, or accelerate in the direction of the force. If the direction of motion is called the positive direction, then both the force and acceleration would also be positive. Now start the toy car moving and give it a gentle tap in the direction opposite its motion. Don't tap it so hard that it stops or changes direction. See if you can tap it 2 or 3 times, again without stopping the car. What did you observe? You should be able to conclude that a force applied in the direction opposite its motion causes it to slow down, or accelerate in the direction of the force. If you had defined the direction of motion as positive, then the force and acceleration would both be negative. What happens when no force is applied? You saw in the beginning that when the toy car started at rest, it remained at rest until you exerted a force on it. What happened while it was moving? It probably slowed down some, with the amount depending on the condition of the toy car and the hardness of the surface. but, the amount it slowed was certainly much less than. It was when you exerted a force in the opposite direction.
What is a positron?
Antimatter form of electron with same mass but positive charge. Emitted in decay of radioactive nucleus or as result of collision of high-energy gamma ray with the nucleus.
What is a horsepower, HP?
Unit of power. 1 HP equals 746 W equals 0.746 kilowatts.
If you stand with your back against a wall, can you bend forward so the trunk of your body is horizontal?
Most likely if you're male you will tend to fall forward. While if you're female you are more likely to be successful. Again, the question is whether or not the center of gravity of your body is above your point of support, in this case your toes, or in front of it.
What is a concave mirror?
Curved inward so that the incident rays of light are reflected and can be brought together. Can form real or virtual images.
What is the code division multiple access, CDMA?
Method of sending cell phone calls in which 3 calls are packed together with 6 more calls at 2 other frequencies.
How many nations have nuclear weapons?
The Soviet Union exploded a nuclear device in 1949. It was similar to FAT. Man and was built using information delivered to that country by spies. China, Britain, and France developed nuclear weapons in the 1950s. South Africa had nuclear weapons but abandoned the program. Israel is suspected of having weapons, but has never admitted it. India and Pakistan have both tested nuclear weapons. Iran and North Korea are suspected of developing nuclear weapons. By 1953 there had been 50 above-ground tests of nuclear weapons that created radioactive fallout, contaminating milk and animals. These effects alerted the public to the danger of such testing. The Cold War, however, created an atmosphere in which treaties could not be negotiated. In 1963 a partial test ban treaty was signed, prohibiting tests in the atmosphere, underwater, and in space. In 1968 the Nuclear Non-Proliferation Treaty was signed. Non-nuclear weapon states were prohibited from building or acquiring nuclear weapons. Many nations have signed the treaty, although some major states did not on the basis that it makes no effort to curb development by states that already have such weapons. In 1996 the Comprehensive Test Ban Treaty was adopted by over two-thirds of the members of the United Nations General Assembly. The United States has signed but rejected ratification in 1999. Nevertheless, 337 facilities around the world monitor compliance with the treaty. They send data to a center in Vienna for analysis and distribution to the states that have signed the treaty.
What is the coefficient of static friction ms?
Coefficient when there is no relative motion between the two surfaces.
In what units is force measured?
In SI, the metric system, force is measured in newtons, abbreviated N. In the English system, force is measured in pounds, abbreviated lbs.
Can quarks be free, or are they always bound in the proton or neutron?
There have been many searches for free quarks but they have never been observed. The theory that describes the interactions between quarks and gluons. Quantum chromodynamics, QCD for short, says that quarks can never break free because the more that the gluons are stretched, the stronger the force they exert. In this way they act like springs whose force also increases the more they are stretched.
Why are the angles of wings important for supersonic flight?
When a plane breaks the sound barrier, the shock wave in front of the plane has a difficult time moving out of the plane's way. In order to break the sound barrier with less difficulty, aeronautical engineers have designed more aerodynamic fuselages and efficient wing designs. As mentioned above, wings on supersonic planes must remain behind the shock front to prevent structural failure and allow the plane to maneuver safely. The swept-back wing design, as found on both military and commercial airplanes, allows the airplane to accelerate easily and faster before major pressure builds up around the wings. The delta wings, as found on many jet fighters, are large and extremely thin. To keep the wings behind the shock front while increasing lift and reducing drag. Problems can also occur when using swept-back wings. As a plane moves faster, the center of lift on the wings can move too far backward, causing unbalanced forces on the plane, which can affect the maneuverability and safety of the plane.
Is there a highest temperature that can be achieved?
Although there is an absolute zero temperature, there is no highest temperature. The highest temperatures achieved to date have been from nuclear explosions, where the temperature can reach as high as 100 million kelvins.
What is a shock wave?
Just as a boat moving through the water forms a series of V-shaped waves, airplanes create conical, cone-shaped, waves as they fly through the air. The waves that the airplane produces are waves of compressed air. When an aircraft reaches the speed of sound, Mach 1, the plane's pressure waves that move at the speed of sound overlap each other, creating a shock wave. The shock wave creates one single, loud sonic boom heard by observers on the ground. When the plane travels slower than the speed of sound, the sound waves do not overlap, and instead of hearing a sonic boom, observers simply hear the delayed sound of the plane. You can think of sound waves as being similar to water waves, emanating from a central source and spreading out in a regular pattern unless they are interfered with.
What is the Leyden jar?
Water can be stored in a jar.
What is a very large array, VLA?
Group of 27 radio telescopes spaced as much as 13 miles apart from each other in Socorro, New Mexico.
What is the threshold of hearing?
Minimum sound intensity that can be heard, 0 dB.
What is the difference between hue and saturation?
Hue is related to the wavelength of a color. Saturation is the extent to which other wavelengths of light are present in a particular color. For example, for the hue red, deep red is saturated, but pink is a mixture of red and white.
What is a synthesizer?
Electronic device that generates, alters, and combines a variety of waveforms to produce complex sounds.
What is weight?
Force of gravity on an object, F equals mg.
How fast does the wind need to blow in order to produce different types of waves?
Wind rubbing against the water surface is a major cause of waves. Since the water cannot keep up with the wind velocity, the water rises and then falls, creating the familiar wave-like motion. Depending upon the wind velocity and the distance the wind has been able to travel over the water, different size waves are generated.
What is a high-frequency, HF, wave?
Frequency 3 MHz 30 MHz.
What is a tidal wave?
A tidal wave, or tsunami, is not caused by windy conditions or tides, but instead by underwater earthquakes and volcanic eruptions. The seismic disturbances create huge upward forces on the water, the opposite of dropping rocks into water. A tsunami is a series of several waves with a period of more than 30 minutes between each. Crest. The ocean first recedes from the beach, then water rushes inland at a very high speed. Large tsunamis can be quite destructive upon reaching the shoreline due to their amplitudes. The most deadly recorded tsunami occurred December 26, 2004, in the Indian Ocean. The earthquake that caused it was off the west coast of Sumatra, Indonesia. That quake released an amount of energy equivalent to 550 million times the energy released in the Hiroshima nuclear bomb. One part of the ocean bottom was lifted by 4 to 5 meters, 13 to 16 feet, and moved horizontally 10 meters, 33 feet. The tsunami, traveling at a speed of 500 to 1000 kilometers per hour, had a low amplitude, 60 centimeters, in mid-ocean, but when it crashed into the coasts from Thailand to India and as far as South Africa, it had an amplitude as high as 24 meters, 79 feet. Some 230,000 people were killed and more than 1 million made homeless.
What is the stainless steel?
A non-rusting alloy of iron and chromium and nickel. May also contain silicon, molybdenum, and magnesium.
What is a critical angle?
Angle at which refracted light angle is 90 degrees.
What is a sublimation?
Change of state from solid directly to gas.
What is the latest fusion reactor research project?
The ITER reactor project is international in scope, including the United States, Russia, the European Union, India, Japan, China, and South Korea. The plan is to spend 10 years in construction and 20 years in operation. No electrical energy would be generated. That would require a more advanced reactor. Using 0.5 grams of deuterium-tritium fuel. It is designed to produce 500 megawatts of energy over 1000 seconds. For the first time in a fusion reactor, more energy would be produced than needed to run the reactor. In May 2010, contracts were signed to construct the first buildings in the project that are sited in the south of France. Fusion reactions are scheduled to begin in 2018.
What is a load?
An engineering term for force.
Where can resonance be found on the playground?
Children discover resonance early in life. When playing on swings, they use their arms and legs to pump themselves back and forth on the swing. They recognize that if they pull back on the chains every time the swing is at its largest backward displacement, they will achieve the largest amplitude. If, however, the pull back at other times, or if a parent pushes at the wrong time, the amplitude will be decreased because the external frequency isn't at the natural frequency.
How does Earth's atmosphere affect the apparent locations at which we see stars?
The light from stars refracts slightly as it enters Earth's atmosphere. Refraction is largest nearest the horizon. As a result, the true position of the stars is a bit off from where we observe them. Refraction of light from the sun results in sunrise being slightly earlier than it would be without the atmospheric refraction, and sunset is slightly later. Refraction also distorts our view of the sun and moon when they are very close to the horizon.
What discovery did James Clerk Maxwell make that depended on the work of Ørsted, Faraday, and Ampere?
In an earlier chapter we have seen that charges create electric fields. In this chapter we have seen that moving charges, that is, currents, create magnetic fields and that changing magnetic fields produce electric fields. In the 1860s, Scottish physicist James Clerk Maxwell, 1831 to 1879, added a crucial additional connection. Changing electric fields can produce magnetic fields. With that idea, Maxwell recognized that these relationships meant that electric and magnetic fields could move through space. The fields move through space as transverse waves that are perpendicular to each other. Maxwell calculated the speed and found that it was equal to the speed of light. He published his results in 1864 and a textbook on electromagnetism in 1873. In 1881 Oliver Heaviside wrote Maxwell's famous four equations in the form they are used today. In 1888 Heinrich Hertz, 1857 to 1894, transmit electromagnetic waves across his laboratory, confirming Maxwell's theoretical work.
What is the third law of thermodynamics?
The third law of thermodynamics states that absolute zero, the lowest possible temperature, can never be reached. The entropy of a system is zero at absolute zero. A procedure can remove a portion of the entropy, but not all of it. Thus it would take an infinite number of repetitions of the procedure to reach absolute zero. It's been possible to achieve temperatures as low as a few billionth of a Kelvin. But it has never been able to reach absolute zero.
What is the Heisenberg uncertainty principle?
Heisenberg, together with Max Born and Pascal Jordan, tried a totally different approach using mathematical matrices. As part of their work, Heisenberg developed a principle that demonstrates that in the atomic world our knowledge is limited. The uncertainty principle is written as AX equals H/4n. In words, the uncertainty of a particle's position times the uncertainty in its momentum is never less than Planck's constant divided by 4n. If it has a precise location, then its momentum, and thus its speed, measured at the same time, must be imprecise. Planck's constant is extremely small. And so the uncertainty principle is important only for objects the size of atoms or smaller. The position and momentum of a baseball, for example, can both be precisely known at the same time. The uncertainty principle shows why Bohr's electron orbits cannot exist. If you know the radius of the circle precisely, then it must have some velocity along the radius smearing out its orbit. The uncertainty principle also exists in a form linking energy and time. In this form it says that if an electron is in a state that lasts for only a short time, then its energy is not precisely defined.
What is a kilogram, kg?
The mass of a platinum iridium cylinder that is permanently kept near Paris.
What is a converging lens?
A converging lens has at least one convex side. Its shape causes the entering light rays to converge, that is, come closer together. A converging lens can create a real, inverted image that may be projected on a screen. When used as a magnifying glass, it creates a virtual, upright image.
What is a wave velocity?
Depends upon the material or medium in which it is traveling.
What is a gear?
Toothed wheels that transmit torque between two shafts. The smaller gear in a pair is called a pinion and the larger one a gear.
What is a reflecting telescope?
Uses a concave mirror to gather light and focus it. Uses a secondary mirror to direct light to eyepiece.
How can you check to make sure a pair of sunglasses is polarized?
Polarized lenses are transparent only to light that has its electric field oriented in one direction. Therefore, if a pair of sunglasses is polarized, two pairs of the same sunglasses, when aligned perpendicular to each other, should not allow any light to pass through the lenses. Light from the sky is also partially polarized due to the scattering of light off gas molecules in the atmosphere. So if you put on a pair of polarized sunglasses and tilt your head so that your ear were near your shoulder, you should see a change in the intensity of the sky on a clear, sunny day. If you see no such change, then the sunglasses are not polarized.
What is an antenna?
Used to transmit or receive electromagnetic radio waves.
What is the Fahrenheit temperature scale?
Temperature scales are artificial in the sense that they are related to temperatures important to humans. The German physicist Daniel Gabriel Fahrenheit developed the first well-known temperature scale in 1714, equipped with the first mercury thermometer. Fahrenheit defined a scale in which the freezing point of water was 32 degrees Fahrenheit and the boiling point was 212 degrees Fahrenheit.
What is a photon?
Packet of light energy, light quantum, by Einstein in 1905. Given name: photon in 1926. Has no mass or charge, but carries angular momentum. Always moves at the speed of light.
What holds a nucleus together?
Protons, all being charged positively, will repel each other. So there must be an attractive force that holds the nucleus together. The strong nuclear force acts between protons and protons. Protons and neutrons, and neutrons, and neutrons, all with the same strength. Because the strong force acts the same on protons and neutrons. The two particles are frequently lumped together under the name nucleon. While the repulsive electromagnetic force acts over long distances. The strong nuclear force only acts between nucleons that are in contact. Nucleons have angular momentum, or spin. And the strong force depends on the relative orientation of the spins. The force is stronger if the spins are in opposite directions.
When was it thought that there were different kinds of electricity?
As you have seen, Benjamin Franklin's kite experiment showed that lightning and static electricity were the same. Since ancient times humans knew that certain fish, such as the electric eel, could shock a person.
How did probability rather than certainty enter into the model for the atom?
In 1926 the Austrian physicist Erwin Schrödinger, 1887 to 1961, published an equation for a wave function that describes the probability of finding an electron at a particular position. It agrees with Bohr's model in that the most probable radius for an electron is that given by the Bohr model. And the energy of the electron is the same as Bohr calculated. But its results are fundamentally different. The solution of Schrödinger's equation can be shown as a probability cloud that shows the most probable locations for the electron. The n equals 1 state of the hydrogen atom is small and spherical. There are two n equals 2 states. The s state has angular momentum 0 and another spherically symmetric cloud. The p state, with angular momentum 1 has two most probable locations, the top and bottom. The n equals 3 state has three possible angular momenta, 0, 1, and 2. The d state, with angular momentum equals 2, has four angular regions with high probability. Red light is emitted when the electron goes from the n equals 3p state to the n equals 2s state. The lifetime of the higher energy state is very short, less than 1/1000th of a second. So when many atoms emit the light, the energy they emit is spread out. The energy from any particular atom cannot be precisely predicted.
What were some of Niels Bohr's accomplishments as an exemplary physicist and citizen?
Bohr returned to the University of Copenhagen as a professor of physics in 1921. With the help of the government and the Carlsberg Beer Foundation, he established the Institute of Theoretical Physics. Bohr's institute attracted all the major theoretical physicists from around the world for short visits or extended appointments. When the Germans occupied Denmark, Bohr made a daring escape. First to Sweden, then England, then the United States. He was a consultant in the atomic bomb development effort, but after the war he tried to get President Harry Truman. 1884 to 1972, and British leader Winston Churchill, 1874 to 1965, to agree to share the secrets of the bomb with all countries, including the Soviet Union. They both rejected Bohr's proposal. But after the Soviets developed the bomb, Bohr's ideas helped found the United Nations International Atomic Energy Agency. Until his death in 1962 he worked to reduce the threat of a nuclear war. In the centenary of his birth, Denmark issued a postal stamp showing Bohr and his wife, Margrethe.
What does sustainable energy mean?
The amount of fossil fuels is limited. There have been major advances in discovering oil and extracting more from existing reservoirs, as well as recent advances in obtaining natural gas and oil from shale. But these sources, as well as coal and uranium, are not being replaced. Sustainable energy sources, primarily wind, water, and solar energy, ultimately receive their energy from the sun, and therefore will be available for billions of years. The present use of these sources is minimal. There are many difficulties in increasing their use. Wind power is highly variable. Water energy from traditional dams and reservoirs causes environmental problems. Energy from waves and tides has yet to be developed widely. Solar energy can be directly converted to electricity using photovoltaic cells. But these cells, at least at present, are inefficient and costly. Large solar farms exist, at which solar energy heats a fluid so it can boil water to use with steam turbines driving electrical generators. An additional problem in increasing the use of many of these sources is that they require the use of very rare materials, which are both costly and not easily obtained. Nevertheless, recent analyses suggest that a combination of nuclear, wind, water, and solar energy could replace most of the use of coal and oil for electric energy production.
What causes materials to be attracted to magnets?
The ultimate cause of magnetism is electrons. When electrons are in a magnetic field, the forces they experience cause them to move in tiny circles. The circling electrons create their own magnetic fields that give rise to diamagnetism. Electrons are tiny magnets themselves, with north and south poles. In most atoms these magnets are paired so their fields cancel. But, if there are an odd number of electrons, the unpaired electron produces a paramagnet. Oxygen, for example, is paramagnetic. In ferromagnets the unpaired electrons in large groups of atoms interact with each other so that they point in the same direction. This group is called a domain. When a ferromagnet is put in a magnetic field, the domains can line up with their poles facing the same direction, making the material a magnet. In most materials, when the magnetic field is removed, the domains revert to their former random directions and the material is no longer a magnet. For certain alloys, however, the domains remain aligned, resulting in a permanent magnet.
How does this very small gravitational field keep the Moon in its orbit?
The answer, of course, is that the Moon has a large mass. 7.2 x 1022 kilograms, and so the force on it is 2.0 x 1020 n. When we explore orbits later, we'll use this result.
What do pounds per square inch, psi, measure?
Measure of pressure in English system.
How is Earth's magnetic field oriented?
Because opposite poles attract. The north pole of a hanging magnet or compass must point toward a south pole. So, the south pole of Earth's magnet must be near the north geographic pole. The poles are actually far below Earth's surface, so Earth's field is not parallel to its surface.